Hello, thank you for watching this video. So on this video, we're doing question 7 of November 2021 question paper mathematics paper 2. The topic is trig functions. So I'm going to read question 7 statement and then answer the questions that follow. So let's go. They are saying in the diagram below, the graph of f is drawn for the interval from x is equal to minus 180 degrees to positive 180 degrees. So they're just telling you what you can see here. You are given the function f, which is defined by f of x equal to minus for the interval from minus 180 degrees to positive 180 degrees. So here is f, as you can see here, and it's drawn from minus 180 degrees to positive 180 degrees. That's what they're telling you. Straightforward, not a problem. They are saying now, on the grid provided in the answer book, draw the graph of g defined by g of x is equal to cos x minus 60 degrees for the same interval as this one. So they are saying now, on a grid which is on the same axis as this one, right, on the same Cartesian plane as this one, draw this function here on the same interval. That's what they are saying you should do. So we'll plot this function on the same interval, which is the same minus 180 degrees to positive 180 degrees. So we'll use the calculator to find the values, values of this function that we're going to plot here. No problem. I'll try to move closer with the calculator and then try to show you guys how to use the calculator to plot a function. I think many of you might know, of course, but for those who don't know, just in case. So here is my calculator here. So what do you do first? You want to plot g of x is equal to cos x minus 60 degrees. So what will you do? You say, you go press mode here. And then you say table, because you want a table that will give you the values that you're going to plot. Table is option 3. Then you press option number 3. Then it gives you f of x there. What is your function that you want to plot? Or maybe you can pass it and say equal to. Oh, okay, it seems like you can't. Then the function that you want to plot is cos, press your cos, x. Where is your x? Your x is, I can't see very well. Yeah, so your x is here. So to find this x, you say, and then go to this here, x minus 60 degrees. So minus 60 degrees. Here is it. Then you close your bracket. So this is what you do. After punching this, say equal to again. Where do you want to start? You want to start at minus 180 degrees. 180 degrees. Where do you want to end? You want to end at 180 degrees. Punch your 180. Say equal to. Then what do you want to step by? If you can look at the diagram there, you stepped by 30. So you want to be consistent. Because say 0, 30, minus 60, 90, 120, 150, up to 180. So you want to preserve the same step. So what do you say? So let's step by 30 degrees. So equal to. So your 180 degrees, minus 180 degrees, you're going to plot it against minus half. Then minus 150, you're going to plot it against that number. That's what we'll be doing on the board. So I'm not sure if that was very clear, but let's plot it now. I'll use the red ink. So seem like 180 degrees plots with a negative half. So I'll say maybe a negative half is somewhere here, right? So minus 180 plots with a negative half. Here is it. Minus 450, which is this, plots with a negative 0.9. So minus 0.9. Let's say somewhere here. Here is it. Your 120 degrees plots with minus 1. Here is it. Yeah, so minus 1, sorry. Minus 1 is somewhere here. And then minus 90 degrees plot with 0.9, which is somewhere here. Minus 60 plots with 0.5, which is somewhere here. And minus 30 plots with 0 degrees, which is somewhere there. 0 plots with 0.5, which is 0 is here. 0.5 should be somewhere here. Plots with 0.5, there it is. Your 30 degrees plots with 0.9. I'll say my 0.9 maybe somewhere here. I think my 0.5 is very high. Let me clean this 0.5. 0.5 maybe should be somewhere here. I can accept this. Say 0.5. 30 degrees 0.9. Here is 0.9. 60 degrees should be 1. Here is 60 degrees. 90 degrees should be 0. What? Oh, wait a minute. 60 degrees should be 1. So here is 60 degrees. Should be 1 there. 90 degrees should be 0.9. Oh, sorry. This was 0.9. So 1 should be above, maybe here. 90 degrees should be 0.9. So 0.9 is somewhere here. 120 degrees should be half. 120 is half. 150 should be 0. Here is 150 here. And 180 degrees should be negative half. So negative half was somewhere here. So it should be here. So if you plot this graph, it should look something like this. The 180 should be here. Yeah, should be similar to this. I know it doesn't look very nice here, but I'll try to fix it and see. So it should look something like this. So this function is g, this one. Everyone should know how to plot a function at least. So I'm happy with this one, and then I think we'll move. Okay, so now we're doing 7.2. That's saying write down the period for f of 3x. They want us to write a period. They want a period for f of 3x. Right? So what you're given here, you're given f of x to be what? To be negative 2 sine x. That's what you're given, right? So if you want f of 3x, which means on this function here, where you see x, you put that, you substitute that. For example, you know, if you want fx0, what do? You say, okay, I'll substitute 0 here and substitute 0 there, right? So your f of 0 is equal to 2 sine 0. That's what f of 0 is. This is an example. So if you want f of 3x, your f of 3x is equal to, where you see your x, you substitute to what? 3x. So you have negative 2 sine 3x. This is what you have. This is f of 3x. So they want you to find a period for this thing here. Right? So, as you might know by now, if you want a period for something like sine kx, right? Or cos kx is always equal to 360 divided by k. Right? It's always 360 degrees divided by k. The k is the coefficient of x, and the coefficient of x here is what? Coefficient of x here is 3. The coefficient of x here is what? Your coefficient of x here is 1. So, if you want a period, maybe for tan kx, it's going to be called 180 degrees divided by k. That's how you calculate the period if you are given a full equation like this one, or a full equation like this one. In that case, if you want the period of f 3x, which is period of what? Of negative 2 sine 3x, is going to be 180 degrees. Sorry, because this is sine, right? If you have sine or cos, It's going to be 360 degrees divided by k. So you have sine there, so it should be 360 degrees divided by k, and your k is what? Is 3. Therefore, the period of f at 3x is equal to the answer of that, which should be 120 degrees. So that's how you calculate the period. You look at the coefficient of x here, or at your function of interest. But in this case, we're not calculating the period of f. We want the period of f at f of 3x. So f of 3x, you have 3x there. And what will that give you? It will be 360 divided by k, and the k is 3 in that case. If you wanted the period of this one, of the original function, it was going to be 360 divided by 1, right? Because the coefficient of x is 1 there. So your period was going to be 360 for the original function. As you can see, it's 360 because it started there and ended there, right? Because a period is one complete oscillation or one complete wave. If you look at this, the wave starts here, go down, go up, and return to that position. So from there to there, it's a complete wave. You have a complete wave if you start from this point here to that point. Because after this, it's going to repeat. So you want to measure the length of that repeating part. And that repeating part is from minus 180 degrees, and it goes back to this. If you can continue, it will do the same shape. It will do exactly the same thing. Similar with the green one, it started there. It went up, down, back to the starting position. If it can continue, it will duplicate, it will repeat exactly the same cycle. So these functions are called periodic functions, like the sines, cos, and tans. They are called periodic functions because after a certain period, they keep repeating, right? So g is a periodic function because it continues, because now it's one single wave, which gives you the period, because its length will be the period. So this minus that gives you the period, which is 180 minus 180 gives you the period, which is 360 for the red or green function. But now f at 3x is a different situation. So your period is called 180 degrees. This is how you calculate it if you want to use some sort of formula-like approach. But yes, that's how you do it. So I'm done with this one. So I'll go to 7.3. So let's go. 7.3. That's saying use the graph to determine the value of x in the interval from minus 180 to positive 180, which the difference between the function is equal to 1. Right? This is 7.3. They want the value of x, right, for which the difference between your functions, right, which f of x minus g of x is equal to 1. So they want the value of x for which the difference between the two functions is equal to 1, or the height between the function is equal to 1, or the distance between the function is equal to 1. But if you look from here, at this point here, this is a half and this is 0, so the distance is a half here, right? So maybe at some point here, I don't know, but here it's 1 minus 0.89. So you must find a point on a function that you can see by your eyes where the distance is 1 between them. But look at this one here. At minus 30, you can see the x value is what? Is 1 here at this point. And the x value there is what? It's 0 on the right function. So your f at 0 is equal to 1. You can see f at 0. Sorry. Your f at minus 30 is equal to 1, which is your function f at minus 30 is equal to 1. Right? And your g at minus 30 is equal to 0. As you can see, g is 0 here. So the difference between these, so f at minus 30 minus g at negative 30 is equal to 1 minus 0 which is equal to 1. This is the point, this x is equal to minus 30, is the point where the difference between the functions is equal to 1, or the distance between the functions is equal to 1. Because you can see the vertical height here is equal to minus 1. It's what you can see by your eyes. Here is it. It is equal to minus 1. And I think it's clear. So, I'll move to the next question, which is 7.4. 7.4. So, what are they saying at 7.4? They'll say write down the range of k, if k is equal to this. So, they want you to write what? The range of k if k is a function of x is equal to half of g of x plus 1. No problem. So they want us to write the range of this thing. So what is the range of a function? A range of a function is a set of y values that your function is using, or that your function uses. Right? That's a definition, or that's how a simple definition of a range. It's a set of y values that your function is using, or is allowed to use. That would be a nicer way. So, now k of x is defined to be this function. We're given that g of x is equal to cos x minus 60 degrees. That's what we were told. So, k of x is equal to half of g of x. G of x is this. So, it's half cos x minus 60 plus 1 degrees. Plus 1 unit. Then, you want the range for this thing. Now, the way I usually approach this, I always start with what I know, with the function that I know. The function that I know is this one. And then from the function that I know, I try to recreate this situation here. I start from this function that I know and try to create this situation here. No problem, let's do that. Where is g of x? G of x is the red function, right? What y values this function is allowed to use, that is the range of the function, the set of y values that your function is allowed to use. If you look at it, its maximum value is 1, and its minimum value is minus 1. So this function is allowed to use the values between minus 1 and 1. So from here to there, that is the set of y values that this function is allowed to use. So from minus 1 to 1, it's allowed to use those y values. So this is the range of this function. So if you think about this, your g, I'll start with g. G, which is cos x minus 60 degrees, is less or equal to 1, but greater or equal to minus 1. That's what we have. We know this is the range of g. This is g, because g is equal to that. And this, when you look at it, it's allowed to use only these y values that are there. Then from what you can see, you try to recreate this situation here. What do? You can see what's the difference between this and this. This is multiplied by half. So if you want to have this slope, this similar slope here, multiply the whole thing by a half so that you can have a half in front of this cos so that it looks like this one. So let's multiply the entire thing by a half. So if you multiply by half here, you'll have minus 1 over 2 is less or equal to 1 over 2 cos x minus 60 degrees less or equal to, multiply by half there, 1 over 2. That's what you do. That's the first thing you do. Now, you look at this and that. What is the difference? The difference is you have a half, here's your half, you have a cos, here's your cos, but you have a 1 there, which is what you are missing here. So to get that plus 1, you must add 1 all across the whole thing, right? So you're going to have minus half plus 1 less or equal to 1 over 2 cos x minus 60 degrees. Then you add your 1 less or equal to half plus your 1. So what is the answer to this? This is the half, which is less or equal to this. What is this? This is k, if you look at it. So you have your k of x to be less or equal to 3 over 2. So they say they wanted the what? The range of this thing. So here is your range. Or you can say your y is an element of 1 over 2 to 3 over 2. That's it. That is your range for your function. And I'm done with this question. And I hope it does make sense to you as it does to me. Thank you for watching. Cheers.